Okay. Yesterday we dealt with negative exponents. We had some problems working with negative exponents. Are there any there you'd like to see worked? Any you had trouble with? Anthony?
First question I have is the answers in the back of the book all have the negative exponents. Should we have made them?
Doesn't make a bit of difference. Either way is acceptable. The only time you have to get rid of negative exponents is when that's the direction.
Okay.
Otherwise, there's nothing wrong with an exponent. And the reason we did that is so you understand exactly what a negative exponent means. Now that we know what it means, if our answer is a to the negative 2, this is acceptable. Or if you want to write it 1 over a squared, either one is acceptable now. Okay? Problems.
Oh, 51 and 52.
51 and 52. On those you have to show by a counterexample, I believe. And that, by counterexample, means plug in numbers. Show that it doesn't work using just one time. Pick a pair of numbers, show that it does not work. So let me show you. Here, we have to show that x plus y to the negative 2 does not equal 1 over x squared plus y squared. And we can show that very easily. Let's suppose that x is equal to 3 and y equal 4. So every place I have an x, I'm going to put in a 3, and every place I have a y, I'm going to put in a 4. Okay? So here this gives me 3 plus 4 is 7 to the negative 2. Well, 7 to the negative 2 power is 1 over 7 squared, or 1 over 49. Now over here we have 1 over 3 squared, well that's 9, plus 4 squared, that's 16. Well, 9 plus 16 is 1/25, and notice they're not the same. And that's what it means by counterexample. Pick out a pair of numbers, any pair, show it doesn't work. Okay? Any other problems in that group? No? Well, let's go. Yes, Kathy?
37.
37.
Oh,
No.
I mean, that was last time,
Yeah.
wasn't it? Okay, we got it. I did it.
Okay, let's go on.
I had to do that.
We're dealing with exponents, and what we have done is we have extended our exponent system. Before we came to this course, we only were able to deal with positive whole numbers. So far we introduced 0 as an exponent, and we introduced negative exponents, whole numbers. Today we're going to talk about fractional exponents. X to the a over b power. Fractional exponents. Now, remember, when we have an exponent, it tells us something. When we add a positive exponent, it says write that base that many times. In other words, x cubed means write x 3 times as a product. 0 told us something. It said anything to the 0 power is 1. A negative told us something. A negative exponent says write the reciprocal, make the exponent positive. Likewise, a fraction exponent tells us something. The numerator says raise to this power. The denominator says take this root. Numerator raised to the power, denominator take this root. Example. Let's suppose we have, let's see, let's start with a nice easy one. 4 to the 3/2 power. 4 to the 3/2 power. Does anyone have any idea what 4 to the 3/2 power will equal? 8. Very good. 8. How do we get it? Well, we follow the rules of fractional exponents. Numerator says raise to this power. Raise the base to this power. So what we have to do is raise 4 to the 3rd power. Well, if we do that, we come out with 64, right? Now it says, hey, take this root of that number. Take the second root. The square root of 64 is 8. And there's our answer. Now, what I like to emphasize here is makes no difference which one you do first. If I would have taken the square root of 4 first, the square root of 4 would be 2, raise it to the 3rd power. 2 times 2 times 2 would be 8. So no matter which way you do it, you're going to get the same answer. But I'd like to show you another example. Now let's see. This is take 27, raise it to the 4/3 power. Now if we raise 27 to the 4th power, that's going to take us 10 minutes. But let's show you how nice and easy it is the other way. It says take the 3rd root of 27. What is the 3rd root of 27? 3. And what do we have to do with that 3? We have to raise it to the 4th power. That means 3 times 3 times 3 times 3, which is 81. So you see, it's much easier to take the root first. Take the root first. Then raise to the power. Let's suppose we have 25 to the 1/2 power. What would 25 to the 1/2 power give you? Help. Madupi? 5. Everybody see 5. It says take the second root of 25. That's the square root of 25. The square root of 25 is 5. And it says raise it to the 1st power. 5 raised to the 1st power will be, let's suppose we have 8 to the 1/3 power. 2? Everybody see 2. It says take the 3rd root of 8. The 3rd root of 8 is 2. Raise it to the 1st power, you get 2. Let's suppose we have, let's suppose we have 9 to the 3/2 power. Nine to the 3/2 power. What would that equal, Beeb?
27.
27. How we get it? Well, it says take the second root of 9, that's 3. And what you have to do is raise it to the 3rd power. The most frequent mistake students make in dealing with numbers and power is this problem right here. So often they want to write 9 for an answer. And it's not. It says 3 times 3 times 3, which is 27. Okay? What if we have 32 to the 3/5? Kathy, you have something?
8.
8, sure. Now this is arithmetic. It says take the 5th root of 32. What we mean there is what number times itself, times itself, times itself, times itself. 5 times will give you 32. Well, that's 2. So what we come out with is 2 to the 3rd. Well, that's 8. Okay? Let's suppose we have the quantity -8 raised to the 4/3 power. -8 raised to the 4/3 power. Mike, you have something.
16.
16. Positive 16? Negative 16. Well, let's find out.
Well, it's probably because we got an even.
Yeah, very good. You convinced yourself. Very good. Negative. What we do here is we take the cube root of -8. What number times itself will give you a -8? What's a -2? So what we have is a -2 raised to the 4th power. That means we're going to have 4 -2s, the product of them. Even, positive, 16. Okay? Nice, simple. Oh, let's see. Let's suppose we have this nice easy one. 49 to the -1/2 power. 49 to the -1/2 power. Tim.
-7.
-7. Anybody agree with Tim? No. Madupi. 1/7. Yeah, that's right. Let's see how we get 1/7. This is 49 to the -1/2 power. The first thing we're going to have to do is get rid of a negative exponent. To get rid of a negative exponent, we write the reciprocal of the base. That means what is being raised to that power to 49? 49 is our base. We write the reciprocal of it, and we make the exponent positive. So this is what we did. We got rid of the negative exponents. Now, the fraction. We have 1 over, well, this is take the square root of 49, that's 7. Raise it to the 1st power, we get 7. So the answer is 1/7. Yes, Kathy?
Can you do it another way?
Yeah, you can do it other ways. You can take the square root, get 7 to the -1.
That's what I mean.
Right. It's always simpler to get rid of the negative exponents first.
Okay.
Here it's not too bad when this is a -1. But when we change it, it might be a little bit more cumbersome. Let's take a look at another problem. Let's suppose we have 25 to the -3/2 power. Okay, Wong, what'd you get for that?
1/5.
1/5. No. No. Kathy?
1/125.
1/125. Yes. Yes. You forgot to raise it to the power, Wong. The first thing you do is get rid of the negative exponents. If we do that, we get 1 over the base is 25. We now make the exponent positive. Now that's what property number 8 says. X to the -n is equal to 1 over x to the n, no matter what the exponent is. Now we have to simplify that. We have 1 over, well, the square root of 25 is 5, so we have 1 over 5 to the 3rd, which is 1 over 125. Okay? Nice, simple. Okay, let's suppose I have x to the 1/2 times x to the 2/5. This should be interesting. Help. What will we get for the answer?
I got the square root of x times...
Nope. 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 That's not correct. Mike, you get anything yet?
X to the 4th.
I didn't get that. Helen, did you get anything yet? Nope. Madupi, tell everybody what the right answer is. X to the 9/10. Correct. How do we get it? Well, Mike, what does it say to do with these bases? What's the operation?
Numerator,
What's the operation here?
multiply.
Multiply. Anytime we multiply like bases, property 1 says keep the base, right, Mike? And do what with the exponents? Add the exponents. 1/2 plus 2/5. Arithmetic problem. We have to find an LCD. What is the LCD? 10. That means I'm going to have to multiply this first denominator by what? 5, multiply the top by 5. Second denominator, 2, multiply the top by 2. I come out with 9/10. See, the rules didn't change. They still stay the same. Hopefully you know how to add fractions. Let's try another one, now that you know what to do. Let's suppose we have a to the 2/3. Well, let's make it a rough one. A to the 5/6. A to the 1/2.
You reduce them.
Anytime you have a fraction that's reducible, it must be reduced. Anytime you can simplify a fraction, you must simplify a fraction. This one came out pretty. Purely accidental. Did it come out pretty for you, Mike?
It came out even.
What'd you get?
A to the 3/1.
A to the 3rd?
No.
What's, is that what he said?
No, 3/1.
3/1? Same thing as 3, right? A to the 3rd? 3/1? Same. That's correct. Here we go. We're multiplying like bases. That means we keep the base. And what do we do with the exponents? Well, we add them. We have 2/3 plus 5/6 plus 1 plus 1/2. But the 1, oh, did you see it up there? Yeah, there it is now. Okay? That's why I threw it in there, because I figured some of you would just ignore it because it doesn't have a fraction. Now our job is to find an LCD. Our LCD is going to be 6. We want to make each one of our denominators 6. That means we have to multiply this first denominator by 2, the numerator by 2. Second denominator is already 6. We leave it alone. Leave the numerator alone. Third denominator, we have to multiply both top and bottom by 6. Last fraction, we have to multiply both numerator and denominator by 3. There we made it a single fraction. We add these up correctly. We come 18 over 6, which is equal to 3. A to the third. Okay? Let's try this one. That's x to the 5/6 divided by x to the 3/4. There you go, Tim.
Was that right?
Mm-hmm. Congratulations.
Couldn't believe it.
Yeah, I couldn't either. Okay. Huang,
X 2 over 24.
2 over 24. Now remember, somebody asked me a question at the beginning of class. Anytime a fraction can be simplified, can be reduced,
Okay.
it must be reduced. You don't say, hey, I feel like doing it today, tomorrow you don't feel. It's always, anytime.
S 1 over 12.
X to the 1 over 12 power is right. Okay, let's see how we get it. We're dividing like bases. Well, we said anytime we divide like bases, we keep the base and we subtract the exponent. Now the word subtract means add the opposite. So we have 5/6. The opposite of 3/4 is a negative 3/4. Now our job is to combine these. Well, in order to combine these, we have to find an LCD. Now what Wong did is he found a CD. He didn't find the LCD though. You just find the common denominator. It works, but you have to remember to reduce it. The LCD for this problem would have been 12. That means we have to multiply this fraction by 2. We multiply the top by 2. We get 10. Here we have to multiply this denominator by 3. We multiply the numerator by 3. So we come out with 10 and a negative 9. That's a positive 1, 12. There's the answer. Okay? Simple. You see, the rules aren't changing. The rules stay the same. Let's try this one. Directions. Write in simplified form without negative exponents. That's a page. X, A to the 3/2, B to the negative 5/3, all over A to the negative 13/2, B to the 4/3. Write that as a single fraction in simplified form without negative exponents.
The last one, 13 over 2.
Yeah, negative 13 over 2. Negative.
Okay.
B to the 4/3. Thirds.
Third.
That's negative 3/2. Oh, okay. I don't know what you're doing there, Luke. You got me confused, but that's okay. I probably did it to you once or twice, too.
Is it negative 3/2?
What's that?
The plus A is it negative 3/2?
3/2, negative 3/2.
Whoa.
Oh, well.
That's negative 3/2.
3/2.
A to the negative 3/2.
Oh, that's a negative.
The denominator is A to the negative 13/2. Oh, I'm sorry.
No, it doesn't look
Yeah.
like negative.
Yeah, it's positive 3/2, you're right. That was left over from last problem. A to the 3/2, B to the negative 5/3.
No, it works out great.
A to the, well, it would have worked out great either way. It would have worked out great.
Yeah, okay.
A to the negative 13/2, B to the 4/3. Either way, they would have came out to be whole numbers.
Yeah.
What's the numerator?
Okay, everybody done? Helen, did you get an answer? No. No. Kathy?
A to the 8th over B to the 3rd.
That's it. A to the 8th over B to the 3rd. Now remember what we do. We're going to bring everything up on the numerator. We have an 8. Now remember, when we divide like bases, we kept the base. We have it there. Now we're going to subtract the exponent. Subtract means add the opposite. So we have 3/2. The opposite of negative 13/2 is a positive 13/2. So they're both the same. We made that nice. That's 16/2, which is 8. We have a b. And again, we're going to subtract the exponent. That means take the exponent of the numerator, which is negative 5/3, add the opposite of the exponent of the denominator. The opposite of 4/3 is negative 4/3. So we have a negative 5/3, and negative 4/3 is a negative 9/3, which is negative 3. And there we have simplified that fraction, but we have negative exponents. Our job was to express this without negative exponents. Our answer is A to the 8th over B to the 3rd. Okay? Okay, let's suppose we have A to the 20th, B to the 12th, all raised to the 3/4 power. Okay. Help. What we get?
I got A to the